I'm Ethan Kern, and in this video today I'm going to be showing you the steps that I take to create toolpaths for an electric guitar in Fusion 360. One of the first things that we need to start off with is the sketch. This is the center tree here, and it has all the critical dimensions and locations for all the pockets and drills. The next part is the profile and the electronics pocket here. There's a few things to note and a few modifications that can be made to these sketches that will allow for simpler toolpaths and a better finished product. The first being that this top edge of the neck pocket right here extend past the top of your profile by more than at least half the diameter of your cutting tool. The second is this access to the truss rod. By making this feature its own separate chain, we can create a single toolpath that will efficiently and effectively remove that material. The next feature we'll be focusing on is this electronics cavity. These three holes are for the three-way switch and potentiometers, and then on the back is a pocket that will be machine electronics, while as this outside profile will be a shallow lip that will be used to hold the electronics cover. One thing we need to do to prepare this sketch is to mirror those two profiles along the center line of the guitar. And then we'll delete the original. We're going to exit this sketch and create a new sketch called Neck Profile Relief. The purpose of this sketch is to add a few lines that toolpaths will be derived from. Creating these toolpaths will create a break when the profile is machined. This will greatly reduce the amount of chip out that occurs on that sharp point. Go perpendicular to the point where the profile meets the neck pocket, and then just at an angle, making sure not to touch the profile. Just to recap what we've done in preparing this sketch, we've made sure that the neck pocket has extended past the top of the profile. We've ensured that the truss rod accesses its separate entity. We've added a relief for the neck pocket, and we've mirrored the beam plate around the center line. We'll now begin adding tools to our library. I found that for most purposes, the sample inch aluminum feeds and speeds work very well for starting out. To add tools, we simply find the tools that we'll be using them, and then click and drag, and then insert them into our drawing. We've got a 5/64 bit drill bit, a 3/16 drill bit. We'll be using a 1/4 inch drill, a 1/4 inch flat end mill, and also a 1/2 inch flat end mill. We've got our tools selected. Now we're going to edit them to make sure they match the physical tools we'll be using. The flutes on this are too short, so we'll need to lengthen them to make sure that they cut deep enough. If you're using a tool changer, you're also going to want to make sure that you number the tools in accordance to where they are in the tool changer. We want to go through all the tools and make sure that they're all set up correctly. The drill bits are pretty standard. We just want to make sure that we have them numbered for our tool changer. With the tooling finished, we'll now create setups for the front and the back. We'll be placing the origin at the selected point. This will be the X and the Y axis 0 on your machine. Wherever you place this point in the drawing will determine where you need to zero your machine before you set up and run bodies. We'll label this setup back and create another one for the front. We want to ensure that the selected point is at the same spot in both setups. This will be critical to the alignment when you flip the body. We'll label this setup front. Now we're going to activate the back setup and create a new folder for each tool that we're going to use on the back side. The first one we'll label 250 drill. We'll create a new folder and then label this one 500 end mill. We'll click to activate the front and create folders for each of the tools in there. The first one being the 500 end mill. The next folder we'll create will be a 078 drill. We'll have a 1/4 inch end mill next. And finally, we'll have a 188 drill. These folders will help keep the toolpath organized within each setup. We'll now activate the 1/4 inch drill folder and create a drilling toolpath. We'll select the tool and that'll pop up our tool library. We'll select the drill that we've already edited. In the geometry tab, under hole mode, we'll go to selected points and select the centers of our ferrule hole sketch. From there, we'll set the height. The bottom height should be -1 inch, as that's the depths of our drills. When we hit OK, it'll calculate that toolpath and we'll be able to see the 1/4 inch holes. We'll label this as ferrule holes and then move on to the 1/2 inch end mill. For this tool, we're going to be using a 2D pocket. Again, we'll select our tool and that'll pop up the library. We need to select the geometry, and we're going to be doing the outside lip first. We want to make sure that the arrow is pointing inward, and the part that's shaded is what will be cut. And this will go to a depth of 0.125. We want to change the step over to about half the diameter of the tool, so since this is a 1/2 inch bit, we'll go to 1/4 inch, and we want to select use morph spiral, and we don't want to leave any stock. When we hit OK, you can see the toolpath pop up, and we'll label it as electronic slip. We'll now create the toolpaths for the electronics pocket. Again, we're going to select 2D pocket. Our 1/2 inch end mill is already in there with all of our feeds and speeds. We're going to go to geometry and select the internal for the pocket this time. We're shaded on the inside, so that's a good sign. We'll go to heights here, and the depth of this pocket will be -1.55 inches. Under the passes tab, we want to change our step over to half the tool diameter again, 0.25. We're going to use the morph spiral. We don't want to leave any stock. And this time, since we're going pretty deep, we're going to use the multiple depths tab. For the step down, I'm going to set to 0.375, and I would like to use even step downs. And then you can see that we've generated that toolpath. And if you hold down Control, you can select multiple toolpaths. And this is all of the toolpaths for the back side of the guitar. We'll label this as electronics pocket and move on to the front. We'll now move on to the 1/2 inch end mill on the front side. Again, we're going to be using the 2D pocket with our half-inch end mill. To select our geometry, we're going to choose the neck pocket. As you can see, that's shaded. The depth of this will be -0.74. As far as the passes go, we want to change our step over and don't leave any stock. We're going to use more spiral, and we're going to do multiple depths again on this with the same 0.375. We'll label this as neck pocket. And then we're going to do the same thing for the pickup pockets. So a new 2D pocket. We got our tools. We're going to select two geometries this time, and we'll click this arrow to change it to the inside, so we're actually milling out the pickup pocket. And same with that one as well. So now we're selected the inside of both of these features. The depth of these will be 1 inch. And then the same routine with the morph spiral, step over, and stop delete. And these, since these are 1 inch deep, we're going to need to set the step down as well. And now, the last half-inch end mill on the front we're going to do is for the truss rod axis. So we're going to select that as our geometry, and the height of this is going to be the same as the neck pocket, -0.74. And then we don't want to leave any stock. We'll set the step over again and more spiral. But since this is so small and we're not going to do multiple depths on this, what we are going to do is come down here to the ramp and change this so it should ramp all the way down. Just like that. So it's constantly feeding down in the same motion, and this will help, since the neck pocket and pickup pockets will already be milled at this point, you will greatly reduce any chip outs while you're milling this feature out. We'll then label the tool paths we just made. And then we can select all of them to see all of our tool paths for the half-inch end mill on the front here. You can see how we're taking multiple depths on several of them. And it's looking good so far. Next up, we'll create drilling tool paths for our 5/64 drill. We'll be creating two different ones. The first one, well, let's select our tool first, our 5/64 drill here. The first geometry we're going to select is going to be for the drills for the pickup pockets. So we'll want to select the centers of all 8 of these for both pickup pockets here. And the height of these are only going to be a 1/4 inch deep. Excellent. And then the next drilling tool path we're going to be using for our 5/64 will be for the bridge holes here. So we're going to go to selected points and select the centers of all of these. These are for the string holes for the strings to go through on the other side of the ferrules, as well as the bridge mounting holes. And these will go to a depth of -1 inch. We'll keep them labeled. And now you can see with all of our half-inch end mills and drills, we're on the right track. For all the tool paths we've made using the half-inch end mill, we've been using the 2D pocket. Now that we're moving on to the 1/4 inch end mill, what we're going to be using now is the 2D contour. So instead of creating a pocket, it's just going to use the contour and go on the outside of that line. So we're going to select, the first thing we're going to do is this relief that we put in the sketch earlier. So we'll select our 1/4 inch tool, and under geometry we're going to select both of these lines here. And we want to make sure that the arrow is on the outside of that line, because we want it to create a break, so when it comes and does the profile, with this tool spinning clockwise, it will have a tendency to pull and chip out that sharp point right there. So by creating this toolpath here at the same depth of the neck pocket itself, what we're going to do on the passes though is we're going to create multiple depths, and we're going to do a very, very small step down, so there's less of a chance of this 1/4 inch tool chipping out that. And we'll create even step downs as well, and we'll click OK. Calculate this toolpath. So you can see there's a lot of passes on that, and so when we put this on the neck pocket, you can see how it ends up at the same depth as well, and this will help prevent chipping out. We'll name this neck relief. And then for the next 1/4 inch toolpath, we're going to be milling out the electronic holes here. And we're going to use the same 2D contour with our 1/4 inch tool here. We're going to select all three of these for our contours. And then the depth of this only needs to be -0.2, since we've milled out the back already. The pocket, the electronics pocket at this point will already be milled out, since we do the back before the front. It's not that deep, so we don't need to do multiple passes, and so you can just calculate this from right here. Label it electronic holes. And then the last toolpath we need to create with our 1/4 inch tool, again, will also be a 2D contour, and this will be for the profile. So for the geometry, we'll select the whole profile of the guitar, making sure that the arrow is on the outside, so we're cutting on the outside of our profile in the sketch. The height will be, so our blank thickness is 1.75, but we want to go a little bit below that to make sure that we cut all the way through. In the passes, we'll need to create multiple depths. With the 1/4 inch tool, about a 1/4 inch depth will work just fine. Now, if you're not using a vacuum table to hold your part down and you're just bolting it down, we're going to need to go back to the geometry tab and create some tabs to hold the guitar body into the frame as it's being cut out. We'll change these to triangular, make them 1 inch wide by 0.75 tall, and we want to go to at points. We only need about 4 or 5 of them to really hold it down. So we'll select along the edges here. You want to put these in places that are easily sandable to remove them quickly afterwards. And after that, we can calculate. So as you can see, we've got tabs to hold it in, and we are almost finished with the front of the body. We'll rename this to profile, and the last toolpath we're going to make is the 3/16 drill. So we'll select our drilling toolpath and our 3/16 drill, and this will be for the neck mounting holes. Holes that will connect the body to the neck. So we'll select all 4 of those, and the height is going to be -1.78, and we want this to go all the way through the body. We want to make sure that it clears the blank. So we'll select the drill tip through bottom and calculate that out. And now we have successfully calculated toolpaths for an entire electric guitar. The next section will be on post-processing. Now that we've created all the toolpaths, we need to turn it into code that the machine can understand. We'll start on the back. If you have an automatic tool changer, you can select the whole setup for the back. If not, you'll have to repeat this process for each folder for every tool. We'll start with the back. If we right-click and go to post-process, it'll pull up this post-process window. From there, you need to go through and right here select. Each machine has a different control, and there's a lot of post-processors for a lot of machines. In this case, we use the Centroid control, so we'll select the Centroid post-processor. If we hit post, it will ask us the location of where this will go, and we'll select this on the desktop. We'll name this back guitar. Save. And then this will pop up all the G code that is created from the whole back setup. Now that you have this code, it's almost ready to be put on your machine and ran. Before you do that though, you want to compare it to another piece of code that's already been ran on your machine and proven, just to make sure that it looks very similar. Also, while you're running any code for the first time, you always want to have your hand on the emergency stop, just in case something happens unexpected. Now with the back done, we're going to follow the same process through to the front. Or if you don't have an automatic tool changer, you will need to do each tool individually in the same manner. We still have Centroid up here, and so we can go ahead and post it. We're going to post it to the desktop, and we're going to name this one guitar. And as you can see here, it lists all the tools that I'll be using and the maximum depth for those tools. And if everything looks good, you're ready to run it. And with that, I'm going to leave you with a brief summary of important things to always keep in consideration. Thank you.